So later we will look at the basically this project. We call it Fire WXNet. I want to explain in a little bit more details about the software and hardware we use in that project before we get to the next example, which is the habitat monitoring example. Let me open the paper that the guys have implemented this project, I guess. All right. All right. In this paper, they have implemented, of course, the fire weather net system, and also they put all the data and also the what you call it, the hardware and software requirement for this project. As you know, this project has been implemented in 2005. Some information I have highlighted here. They checked the related work as well, and then they said why the related scenarios and the deployment scenarios not very successful. So that's why they came out with a new system. All right. Let's look at this information. Working together with the firefighting teams and fire researchers, we set out to build a system that could report the weather conditions over a variety of elevations from anywhere within the fire environment. So together, we formulated a set of requirements that drove our design. So let's look at the requirement here. So the weather data, visual data, as you know, is a 24 hours data. Elevational gradient in the right terrain. Long range remote monitoring, we already discussed. The power efficient, the simple and robustness, the low cost. These all are the requirement of the system. All right. So the system they deployed consisted of 5 long-range links, 3 sensor network consisting of a total of 13 nodes, and 5 wireless access point plus 2 web cameras. This is the hardware requirement for this project. So of course they discuss in this paper about the related work. The reason that I'm showing the paper, maybe from beginning you can see how the people write a research paper. All right. So they will start with the answer. I'm sure you are quite familiar with these kind of things, but I just explained a little bit. Maybe for those who did not focus on these kind of things, maybe they can learn a little bit how to write a good research paper. So start with the abstract. So they have a general terms and so on. So then the first session will be the introduction. All right. So they try to introduce their system, and also they will highlight the existing problem in the area. And then the requirement for their system and so on, they will highlight it in the introduction section. In the second section, they discuss about the related work. And now here they can compare their work with the related one, and then they can show the advantage of their system compared to the existing one. Of course, when you are going to write a research paper, you must show that the related work implementation or simulation whatsoever, what is the shortcoming, what is the problem in this area or in the existing method, and how basically you are going to solve this problem. So that's why the related work will come at the second section. In the third one, the system design and implementation, or let's say the purpose method, will be discussed here. And after that, it goes to the implementation, result discussion, and finally conclusion of the paper. So that is basically a method of writing the good research paper. So in the system design, basically they discussed that our system needed to relay data from many points of interest to our base camp that we already discussed. So that's why they need to come up with the satellite dish, right? Because the data they are going to send is about 3 to 50 kilometers long, the distance. So that's why they need a satellite dish as well. So here they discuss about the network setup, all right? So the kit they use and also the area they have put the devices and so on, they discuss. Let's say here in this figure they put the base station and so on at the how do you call it, the point A, for example. And then the sensor and other thing they put it in place F, E, and D. So as you can see, the data are collected from these 3 points of interest and send it to the C, then B, and A. All right. Uh, in this case, they mentioned that the nearest internet connection from the place that they implemented the network is 65 kilometers away. So of course they need a transceiver also. So in that case they use a satellite transceiver. So they cannot put a permanent, of course, satellite there because they don't want to put the equipment forever over there. So what they do is using the portable satellite transceiver. So for their project, after that they can take it back. All right. So the data rate they use for the data transfer is 128 kilobit per second up to 512 kilobit per second. So that is the things they implemented. Also, they use a solar panel for the energy consumption to provide the energy and power for their system. All right. So about these things also they discuss here. So in the next section, they discuss about the weather network hardware. All right. So what type of hardware they have used and so on and so forth. All right. First, they start with the base station. So the RAM required for base station, the base station need processor, of course, the Ethernet port for the, the cable connection, the internet connection. They have the serial port, they have the USB port, the base station itself we are talking. All right. That is the first device. The second one about the sensor nodes. So what type of node they use is a Mica platform, all right, Mica 2 platform with the AA batteries. And also the processor, of course, is only 8-bit processor because, as you know, the sensor node must be very small. So that's why they choose the processor that can be installed successfully on that. And also the built-in temperature sensor. So the temperature can be sensed by this type of sensor itself. And also for the humidity. So two type of sensor was embedded into this system. And also to protect the sensor node from the outdoor elements, but still allow them to accurately record the weather data. They built an enclosure, all right, as you can see in figure 7A and 7B. They use the enclosure, all right, to cover the sensors. But again, they must make sure that this cover do not interrupt sensing the data, all right? That is very important, okay? That is for humidity, they put it like this. If there is a rain or something happening, so it won't affect the sensor, right? And also they use this type of webcam or camera. All right. So about the software, they use a Mantis operating system. So later you will see the different type of operating system you can use for the WSN. All right. In this case, they use the Mantis operating system, which is running on the Unix. Is Unix based, in fact. So the reason they choose it provides the easy to use interfaces. Second, the Mantis can be used on multiple platforms. All right, and it has already been ported to the Mica 2 because if you remember, they use a Mica 2 type of sensor. So the operating system is already there. So that's why they choose to use the Mantis operating system. About the deployment issue, the mechanism, so the places they try to put the sensor, how the data would be forwarded, and so on and so forth. All right. So that is another criteria that they have to uh, take into consideration. So one of the important issue in networking is a routing, how the routing would be done. All right. So if the node power on, if you power on the node for 24 hours, of course the energy will be the energy consumption will be too high, and the node battery will get empty very quickly. So because all the node also must be able to do the routing, as you can see, the multi-hop network. So the energy also is very important. And when the nodes are power on, they can do the routing. Otherwise, they have to do the buffering of the data to make sure that the data are not lost. And of course, they use a different type of protocol as well. One of the protocol for the time synchronization is a network time protocol, or NTP. So the protocol they use for that is this protocol as well. All right. So they consider all of these issues for their implementation, and finally they were successful to get the data like temperature as well as the humidity. And after gathering the data, then they can do the evaluation, sending the data to the base station successfully, and over there you can do the processing. All right, that is a good paper for the environmental implementation of WSN. All right, so let's go back to our slides. The next project that we can mention here is the ZebraNet project. All right, so the collar mounted sensors monitor the zebra movement in Kenya. So later we'll see they need to monitor this kind of movement, all right, to check whether the zebra group or the places or the place they visit, and also all the information they can get it using the sensor. All right, excuse me. So this project, they call it the ZebraNet project. As you can see, the data, they put the sensor on the zebras, and then the data collected from one zebra, in some cases the data would be forwarded to another zebra, and from that to another one, and then finally reach to the base station. All right, and here we can see the comparison between the ZebraNet and the other sensor network. In terms of the node mobility movement, ZebraNet as an animal, they are moving very fast, right? So in this case, the mobility is the network is highly mobile network. But compared to the other sensor network, they might be the static or moderate mobile, not very highly mobile. All right. The communication range, it can be go to the miles, while in the other network maybe go to the meters only. For the sensing frequency, we need a constant sensing. All right, compared to the often, for example, sensing, or not all the time, not constant sensing. And then for the device power, in this case, for the ZebraNet, we have hundreds of milliwatt, but in other network, much more less than that. Right? So that is a comparison between the ZebraNet. This is a requirement basically. You have to look at it. Oh, the design that I'm going to have it is should be for the highly mobile network, and the range is miles. The frequency is constant sensing, and so on and so. These things must be considered before we finalize our design. The next example is a habitat monitoring example. All right. This is a dynamic virtual fences for controlling the cows. right? Even in this project, they put the alarm sound and also shaking the neck of the cows to avoid them to go through the, pass through the fences. So we will see this example implemented in 2004. So the two fundamental different approach to controlling the animal position. The first one is a physical agent. Maybe you can have a sheepdog or robot in your farm to do this thing, or a stimulation device worn by the animal. You can put on their neck and then control them. So a simple collar which provides an electric shock when it is in close proximity to a body perimeter. So we can use this kind of collar to control the cows, right? And we call it the virtual fences project, a combination of robotics, networking, and animal behavior.